database system. When I learned the first time the database, I didn't know anything about the data, what is the information, even what is Oracle, what is the DBMS. I didn't know that. So I just started to study about the data, but fortunately when I learned the database the first time, it was 1996. I think that is 20 years ago. So I just graduated from my undergraduate program, then I majored in the mathematics. To understand the concept of database, the mathematics, the concept was very, very helpful, especially the set theory. So do you remember what did you learn in your elementary or the middle school about the set or set theory? Right? What is a set?
Collection of elements.
Connection of elements. It's a group of elements, right? It's a collection of elements, right? Then why do we need a set in mathematics? Have you ever thought about it? Relatively, in the math, set theory is quite easier than other subjects, right? So you learned a lot of algebra and geometry, equation, formula, theorem, but the set is relatively easier part. But actually, it's much, much more important than the mathematics subject, the set theory. So what is a set? Why do we need the set when we learn the mathematics? Any idea? Why? The set theory, set. Why do we need the set in our mathematics? Just, it doesn't matter, okay? It's not math class, so just express your opinion, whatever, okay?
Oh, the database.
Oh no, you don't have to worry about the database. I'm just asking set theory or set the concept in mathematics, not the computer science.
To solve the problem.
To solve the problem of what? What kind of problem? Do not answer math problem.
Any problem that we see in our lives.
In our lives. It's too broad. What do you think? No idea? Even I didn't have any idea at the time. Anyone? Yes?
It makes easier to add or subtract or doing some...
Yes, that's another important thing,
kind
the
of
set operation. So we can combine, like the intersect or union. And or minus two different kind of group of data, right? So, but when we start to define the set, what is the example of set in your math class?
A set of integers.
Integer is a set. And what else? Natural number.
Natural.
And
Whole number.
so rational number, irrational number, so a bunch of different numbers. That's the key point of the set theory. Unfortunately, we have infinite number in our math, in our life, in the universe. It's an infinite number. So when we define the operation like the plus, minus, or subtract, the times, how can we show a plus b is equal to b plus a? So you need to show all the number. Is it possible? No, definitely it's not possible because we have infinite number. So it doesn't make sense to use the certain operation for the infinite number. It's hard to prove, even sometimes impossible. So how can we define such an infinite number? At that time we can, instead of 1, 2, 3, 4, 5, 6, 7, 8, we can define group of the number as integer, something like that. What natural number? So using such a set concept, we can define, we can manipulate the infinite number. For example, natural number or integer number. Then we can do whatever we want, right? Think about the database. Why do we need a data and database? Because why?
Because we can have like a large amount of data.
Large amount. That's a key point. Okay? If we have small amount, even though that's a very important, it's critical. Like the password to start the nuclear bomb. Do we need to keep in the database system, Oracle database? No, you'd better memorize that password, right? So that's the reason that only the president knows the something secret number. We don't keep such a number. Okay? The main purpose of the using database or data, sometimes people the confuse the main purpose of the data and database. Every time, every moment, while you are using the computer, you are using data. And also database, certain different types of the database. What about the cell phone? When I'm using cell phone, do I use the data or database? Yes, a certain type of the database. Mostly such a data are in the memory. It's a memory base. What about your simple program? Like when you learn the new program, you probably implement, compile, and run the Hello World program, Java or whatever. What about the database in this program? Do we use the data and database here? Yes, we are using memory database. So in your process, so when you compile and run the program, it creates a process. In the process, it has certain data structure. In the process, heap area, stack area. Do you remember the stack area? Store the temporary data, and the heap keep the data, and it has a text information. This heap, between heap and stack area, is your database. You can keep such a data, like I define the integer I in your program, then this is your database and data. It's a very simple. It's enough. Why? Because it's a small. The problem happens when you have very large data and very large information, very large database. At that time, we need certain database. Then we borrow the idea of set. Using set, even we can define infinite number. We can just set, for example, x bar, x is bigger than 3, and x is an integer. So we can define certain number using the set. Okay? Similarly, we can define huge number. So suppose that we have the millions of student information. So for the instead of define integer 1, integer 1, integer 2, integer 3 for 1 million, why don't we define student something? Eventually there will be table or entity in our database concept. So we define. Okay? It's a group of data. Just like the set. A set is group of number. Okay, that's the main idea. Even though some of the professors do not realize why we are using database, where it coming from, really. Fortunately, I major in the math, so I can compare between the set theory and math, and then it was very easy to understand the main concept of the data. Because we have the very large data, even nowadays, the current DBMS relational database not enough to keep big data. You heard about the big data, so that's a little bit different story. We set aside at the end of the semester. Okay, we will a little bit talk about that problem, but still, so if you take a look at the first academic paper that proposed the relational model, whatever that is, you don't have to worry about what is a relational model, what is Oracle, but when they proposed the first time, they mentioned too many very large data. We proposed ABC or certain database model. That is the relational database model. How idea is, why don't we keep the only common thing? So name, ID, and address from student 1. Name, ID, address, name, ID. Same name, ID, and address, and group of name, ID, and address. We have the same format for each element in terms of a set. Okay? Set theory. Then grouping. Then we can easily manage. And when we search the data, it's very fast, such a data, because they have the certain model. It's a template, so it's not very difficult to find the specific student or element. That's the idea of database system. Do not forget such an idea. So whenever we learn something modeling or query processing, was even SQL. So all these application and idea and algorithm are based on such a basic concept of the database. It's a group of data. However, that's a little bit different from what you learned in your programming class. So which programming are you using in your core course? Object-oriented programming, OOP course, right? Is it based on the something relational or the network or whatever? What kind of model you use? Object model. Okay. Object, in terms of the object-oriented model, how do they regard the data? How? What is the data in object-oriented model? It's an object, right? Everything you consider the data as an object, right? Then you can initiate the student object, then you can have the instances. And also, using that such an existing student, we can also have something inherit. We can inherit the characteristic of the student, so graduate student and undergraduate student, good student, bad student, okay? Something like that. So that's the way of object-oriented programming. So we regard the data as an object in object-oriented concept. However, unfortunately, in the database area, in this class, and still in the market, they use a different model. So in the programming level, or the software engineering model, object-oriented concept, object-oriented model is popular, some majority. However, in the database, which one? There uses object-oriented model, but the majority is relational model that we are going to learn in this class. This relational model consider data as a set, group of the data. This one is not group of data. We consider something objects. That's the key point of the object-oriented. That's the huge difference. Because of that, it causes a lot of problem also. Okay? Because of that, it's not flexible. Think about I limit the student as what? Name, ID, address. Name, ID, address. But he has more valuable information like he has the experience on database. We cannot keep such a data. Also, other student from the other country has a different background. But because of the definition of the student, I can keep the only name, ID, and address only. We cannot keep other information. It's not flexible. It's not customized. Also, when we consider the data in terms of the object-oriented model, so student, we can define something, the person object. Then from the person object, we can also create the faculty, the staff, student, because all of them are persons. And for the student, we can specialize. So we can use such a concept, object-oriented concept. On the other hand, the database relational model, no, we cannot do that because we fixed. Okay? So why don't you, the kid, such a difference throughout the semester, try to understand what is the characteristic of such a relational model, database model, then how can we overcome when we are working with the other program languages, that will be helpful when we learn about the database concept like the query optimizing and the transaction management and so on. Okay? Any question? So these are the basic definitions that we already discussed. So quickly, so this is database is a collection of the related data. So related means same format, right? Student, we are not going to keep the faculty information in student set, student table, student database. Okay, only student, they are related. So, however, so when we are saying the relational database model, the relation does not directly means the related. Okay? Instead, relation means more like definition of the database concept. That means the set, group of data. That group of data should be related, okay? So that is a relational model. Then we already discussed of the data. So our goal is to build a database and the database system for the such a real world information. Then, what is the impact of using the database? It's everywhere nowadays. We use the database for the business, the system, and the service industry, education, and even personalized the device, the mobile device, such as the smartphone. We use such a database system, small database system. Okay, but main problem of the current technology on the database system is in terms of the size. What is the thousand of the terabyte? So currently, many of the people are using terabyte level the hard disk drive for the laptop. Mine is the 256 gigabyte. It's not the hard disk drive. It's a solid disk drive. So it's even still expensive. But many of the laptop has something terabyte, right? 1 terabyte or 2 terabyte. Then what is the 1,000 terabyte? It's called gigabyte, next terabyte, next petabyte. So what is the next? Zettabyte and exabyte. Okay? So petabyte size level is enough for the current database technology, especially relational databases. So that's enough for the most of the company. There are not many companies. Their total size is bigger than 1,000 exabyte. But nowadays there is like the Google, Facebook, YouTube, and Twitter. Their database total database size is above petabyte size, exabyte level. So database, for example, Oracle, Informix, DB2, such an existing relational database model can support up to the petabyte size level, but not enough for this. Because of that, we need to think about the different database model that is called NoSQL database. But this is beyond the curriculum. So if you are interested in this part, I'm going to offer the NoSQL database course next semester. But so this will be used for the current application and the system. So this is an overview of the database system. What if we do not have the DBMS software? This the box. Is it okay? Yes, it's okay. So many of the systems actually do not use such a database system. In case you have very large data to be managed, then we can put the DBMS part, database software, to keep such a very large data. What if we do not have the database? How we can manage the data? File system. We can use a file. Even sometimes a file system is faster than DBMS. Why? Because we pay a lot for the Oracle database. Then why Oracle is slower than file system?
Depends on the size of the data. If the data is small, file is much faster than database.
Think about the basic of it. This is a file system approach. This is the database approach. When you manage your data, like me, I'm using Notepad, lee.txt file. Keep all the data in the file. Okay? I'm using Oracle database. So this is Oracle to manage the same data. How can you use this plain text file as a database? In your program, you can open the file, then read the data using fopen or the open the file, whatever the command API you use. Open the file and read the data. Whenever you find the data you want, then return or process. What about this one? You need to install running the Oracle database, it needs a huge amount of the memory size and the process requirement that connect the Oracle database from your application, and this database is run is too much overhead. Okay, so basically, file system approach is faster because it's low level. Then why do we use this? Because we have the very large data. When you have the very large data, this is more convenient and faster. I don't say that this is exact, always faster. This one is faster than this one, but mostly the database approach requires a lot of overhead. Then how can we overcome such an overhead in the database system? One way, index. We can use index. It's like the index part of your textbook. There's a sorted data keyword. Then, just like that, we can use the indexing technique to speed up. So we will learn about the indexing structure, second part of this lesson. Okay? Also, your project will implement specialized indexing structure. It's called the index organized table. Then second, another way to improve the performance of the database system is name. What about the think about why don't you think about the general computing architecture? How can we speed up usually when you use the data? Any idea? Still sleepy?
It's, maybe we deal with the memory.
Memory. Very nice. Let me know when at the end of the semester I will give the extra point. If you are doing very well for your project. Memory. Always, whenever we encounter speed problem in the computing architecture, we use the memory, cache a lot. Okay? Even there is a cache in the CPU, L2 cache, layer 2 cache, and whenever the database, even hard disk drive has the cache, memory, its own memory. So actually DBMS system, database management system, use a lot of memory as a cache. For example, Oracle, when you install the Oracle, it is recommended to use half of the all physical memory. For example, if you have the 16 gigabyte memory in your the database server, half of them should be the reserve for Oracle database cache. Really, sometimes 2/3. Okay, so we will see how we can increase the performance using the memory. Okay, that is a proper management. So this is the database. So we will use such a database software for this purpose. Okay, so this is an overview of that. Okay, then you will, so in your project A, we will use the Oracle database. Okay, install the UB. You don't have to install the Oracle server on your laptop or computer. You are going to remotely connect. Then from your application program, you can use any program language. If you are familiar with .NET, yes, you can use a .NET program. If you try to use Java, you can use Java. Some of the students prefer the low-level language like the C language. So you can use the C language. I have seen only one of the students in my experience to use a COBOL. Do you know what is a COBOL language? It's all the language still used. So sometimes the company are looking for expertise on the COBOL because their old system is based on the COBOL, but it's very hard to find such an expertise. So why don't you try to learn? It's not very difficult. It's sometimes easier than the harder, but you don't want.
That makes sense.
So especially the Y2K, when the year changes from the 1999 to the 2000, the people are crazy. I'm not sure whether you guys remember the Y2K issues. Okay? At the time, many of the companies would like to hire who know the COBOL language because COBOL is a serious They said it was a serious problem, maybe serious, so nuclear weapon will be exploded or whatever, but it was not that serious. But anyway, at the time, many of the experts on old-fashioned languages moved to their job. Okay, so this is the what. So program language, there is no limitation. So from the program, your own program language, connect the database system to get the data. Okay, this data is stored in the hard disk drive. Sometimes it's organized by the DBMS system. It's not like the file system in your operating system. Okay, even though this software is using your file system. Okay. Any question? So, what kind of benefit we can get from the DBMS? What kind of utility, what functionality we can use? So, definitely we can define. So, to use such a set, this is a set, so we define the very large data as a set, which means a relation. Okay, this relation, this whatever that is, should be defined in your database system. Okay, so that's called the database model. Database should be model. It's a structure or standardized. So that is a database model. There are a bunch of different ways of database model. I already gave you the one example, object-oriented model, the database model. You consider data as object. What else?
Hierarchical model.
Hierarchical model. So you can consider data as hierarchical, like this. This is my first database model that I use. When I learned something programming, whatever, it's a hierarchical HDB in IBM. So, bank, there's a bank, and as a branch, there's a branch. Branch 1, branch 2, each branch has customer saving account, and loan account, and credit card information, and branch 2 has subscribing. Benefit? Very fast to access the data. Because it's next, so which is called get next. You can use get next operation, find the next, and finally easily find the data. Problem? Memory?
Overhead memory. Because if it is more entities.
Anyway, this structure will be stored at the hard disk drive. So memory is not the direct problem. Memory can be problem when we search the all customer information. Like I'd like to get the average balance, all bank. How can you access the data? Customer, the saving account is branch 1. Go to here. Another saving account. Go to here. Go to here. So you need to visit all the descendants. Takes a long time. You need to keep all the data in the memory until you finalize. So this is one of the examples of the network model. And what else? Hierarchical model and network model. So we can use some relationship between the data and represent such a relationship as a network. So network database model is possible. So no matter what types of model you use, so your data should be defined in your model. In relational model, we will consider data as a group. Such a group will be defined. Eventually that defined model will be what? Table. So you are going to create the table. I know some of you guys already have an experience on the using relational database, like the MySQL or SQL Server or the Oracle. At that time you create the table, right? And select the data. So create table. Table means define your data. And construct, okay? More important thing is the manipulation. After you create the define and the construct the data, it should be able to retrieve, okay, or modify. So database model, DBMS provides such a functionality, and plus many other things. So that we are going to discuss throughout the semester. So this is our goal to develop. We'd like to develop such a database. Okay? How can we? So this is an example of the what? University. Okay? So we want to build such a university database. At the time, it has, so in terms of the database model, so that I explained, for example, set. This is one set of data, courses. And this is one set of the data section. This is another set of data, another set, and the student set. Right? Then we can make the group of the data. Eventually, we will call each one as the entity, or sometimes it's called the relation. Eventually, it looks like the table, so these are called as the table. But anyway, this is our goal of the class. To do that, we need to first do what? We need to understand the data. In this case, the university sample of the database in university is simple. Everybody knows it has the student information, faculty information, grading section, and so we can easily group such a data. But in real world example, like when you build a database for the NASDAQ, okay, stock market trading system, you should know all the business flow, right? If you build a database for the Google, so you need to know how the Google is organized and how it works. So you should be expertise on your database. It's the same thing. When you are doing the project A, you should know, you should be the expertise on your database. Then find any characteristic, any relationship that we can make the course information, because it can be group or the entity. And group, then find such a thing, and also we can find a relationship. For example, student take the course. That should be reflected in your database design. That is called database design. So first we are going to focus on how to design, how to organize the data. From where? Information. From information, this is the information, then make the something model. This is called data model. Data model is a very high level design. So it doesn't require any specific skill in computer science. No programming. So for example, when you design, when you organize your room, okay? If you go to my room, there are a bunch of the paper and handout and the scratch paper. So when I organize my room, do I need a computer science skill? No, we don't need. Instead, you should know which one is which, right? So I need the database, the paper, then grouping. I need the operating system, the paper or material, and grouping, and file, and you put together, okay? Same thing, when we are doing the data model, you don't need a database skill, okay? You don't need a computer science skill, you don't need a programming skill. Instead, domain knowledge. You should know the data itself, information itself. Okay, that is the reason in real the database design or the project, this will be done by software engineer, developer, no, consultant from the finance, or the consulting group usually from the CPA. Okay, they are doing such a consulting because they know business flow. They know how HR is organized. They know how the university company is organized. Okay, so then output of this one, data model and conceptual model, will be converted to what? Database. That's called the database model. Physical database model. Physical level. Okay, this is a conceptual level. This is a physical level. So first part of the database design, we will focus on this, the logical model or conceptual model, data model. Then second part is physical database model, database model. Okay, to build a database using what? Computer. specifically DBMS, like the Oracle. Okay, so using this one, so we can build a database. There are several interesting features of the database approaching. So we talk about between the file system and database. Can you find any difference between the file system versus the database? Which one is better?
It depends on the way you're going to use it.
Depends on what?
It depends on the way you plan to use data.
And also size of the data, right? So when you have the very large, small data, it will be easier. However, it's not easy. So, for example, when I search my friend's phone number, I need to open the file. Then I should know how this file is organized whenever I access this file, right? Otherwise, you need to go through all the data. So, for example, this one is organized the name and phone number and address, something like that. From line 1 through 10 is further this information like that. Then your application program, your programming language, you should know about this. What about the database? You don't have to worry about it. Why? Database itself has their definition of the data because it's a model, and you use the model to create such a data structure that we have seen, define the database and construct. It's already done. So we don't have to worry about how they are organized. It's already inside. That is called the self-describing nature. So database, one of the benefits of using database is database itself has definition of your data and database. So you don't have to worry about after create. When you are using the file system, you should know. Also, whenever you change the format of your file, you need to change the application program. However, this one, it has, you can just change the definition of your data. Okay? So that is a main difference. For example, in Oracle keeps such a information like the data structure type constraint that describe your database. Store such a data in the catalog database. It's called the catalog database. So, which means when you create the new table, like the student table, definition of the student table will store at here. You can retrieve even. So one time when I worked as a database administrator, so from time to time I consult the small company database system. Because it's such a small company database, it's never been managed. They just purchase the database system and the software, all together. It's called the turnkey project. So it's you don't have to worry about anything other configuration or setup, just turnkey. Okay, then it works. Problem, they do not have the administrator to manage that one several years. So, but it's getting slower. So they ask me to tune up the system and check whether the database is okay or not. At the time, they do not have any documentation. How many tables are there, and what is a table, what is an employee table, and the employee table, what kind of column information are there. But I can search. I can retrieve such a data using what? Catalog database. Catalog database include all description about the database. However, that was not easy even. Why? Because the table name and column name was not the straightforward, which means I expected something employee table or customer table, but they named it like the E1, E2, or C1, C2. Column name, C1, COL1, COL2, something like that. So it's very hard to figure it out, which one is which. So naming is also very important. So that is a self-describing nature. Insulation between the program and data means and you are using file system, if something changes in your file, you need to change it application program, right? So I use the 10 byte for the name and 20 byte for the number and 100 byte for address, but I have the friend whose name is bigger than 50, I 10 byte. So I increase this one. At the time, you need to change it, the application program to access the name, right? Or what the database. It doesn't matter. Okay? When you access the data in your program or in your application, you can just ask what is the name of this student. Then inside the database system should take care of everything. Doesn't matter whether it's a 10 byte or 15 byte or a 12 byte, whatever. It's the abstract level. So that is called the program and data. It's the introduction. Yes.
But when you create like variables or rows in a table, you have to specify the size of.
Yeah. That's when you create the table. After you create the table, it doesn't matter your data is a 10 byte or 20 byte. Even if you change it, the size of the data, so like I create the name as a 10 byte, so change it to 15 byte. You don't have to change the program. In your program, you do not specify the size of the data. Instead, just a name. I try to select the name. Okay, then DBMS will take care where name is. Then it doesn't matter whether it's a 10 byte or 15 byte. That's the benefit of using DBMS because program level and data level are abstract level. It's separated. That's called the integration between program and data. Okay? But that's a little bit different story in the NoSQL database because the NoSQL database, as I said, is a more flexible data structure. Okay? So flexible means we need to do a lot of things in the programming level sometimes. Okay? So it's a little, but in traditional database system, no, you don't have to. So that is called overall data abstraction. Okay? When you are using the database, you don't have to worry about where data is stored, how data is stored. Who is in charge of such a thing? DBMS. DBMS itself will take care of everything. Like I asked the GA, why don't you increase the performance of the student? Then that's it. Then GA will have doing a lot of material and additional section to whatever, right? So it's a abstract. So whatever he is doing, it's okay. He doesn't have to inform me. So I just ask the improving. So it's the data kind of abstraction. Okay. So that is another main characteristic of the using DBMS. What about the file system? You need to take care of everything. Where this file is stored, that's the drawback of using file system. But still, when you have small size data, that's the reason. Okay? So it's very hard to say. File system is better than the database, or the database is better than the file system. It depends on here answer. Another characteristic of the DBMS is supporting multiple view, which means this is a very important data, so I'd like to share this information with my wife. But I don't want to share the information about my girlfriend. Oh. So, for example, it can be viewed different. I'd like to share this file to other person, but I don't want to share certain information. At that time, how can we do that? Not easy using the file system. You'd better create a separate file. Right? And from time to time, you need to synchronize manually. Then this is for my wife, this is for me. What if the student information, student file in the university? So if you are using the file system, but payroll, they want to keep the only payroll, the data, like the social security number and the bank account name. What about the department? Department would like to know the academic information, like the major, minor, and GPA. And what about the HR would like to know the address or demographic information, something like that. It's a different. If we manage the different file for each department, what if I move to the house? Then I need to inform each and every department, right? So which is not convenient and even sometimes not possible. So what about the database? Database, you have only one table for the student. Then it can be viewed differently using something permission or the privacy setting. So you don't have to create the multiple table, instead one table and view different. That is another characteristic of the database. Okay? Also, when you are using the database, what about the file system? So I decide share all information with my wife, which my wife she wants. Then what if when we access the same file, the same time from the multiple application, can you open? No. The other transaction will open this file only read-only. It's the same thing in the Microsoft Word or the PowerPoint. When I double-click the same time for the chapter 1 the document, the next one will be read-only file. Why? Because it doesn't support multiple transactions. What about the DBMS? Nowadays, how many transactions at the same time? So think about the Bank of America. Bank of America has probably a customer table. Then how many transactions at the same time? Many transactions. If you allow only one transaction at a time, you will lose many of the customers. They cannot wait until one transaction is complete and one transaction. Instead, simultaneously many transactions should be able to access such a data. So database system will support such a concurrency control. We will see how we can do it. Is it simple? Just let the many transactions use it? No. Think about the one shared data and allow to use many other students. So let's say in the bulletin board is 1, but student A update the 2. Student B update the 3. Student 3 update is 4. What is the final value? We don't know. We cannot guarantee. Okay? So that is a synchronization problem. If you are related to the operating system clock, it's a synchronization problem. So we need to address the problem of the synchronization. Solution is transaction. For example, when the SQL Server released the first time, Microsoft, like the Microsoft product, SQL Server only for single user. When you have only one user, you don't have to worry about such a concurrency control or multiple transaction because you have only one user. But Microsoft would like to support from the Windows 95, Windows NT, they'd like to support the multiple user login to the one operating system. That's the same thing for the SQL Server. So SQL Server needs such a multiple transaction. Instead of developing new transaction management system, actually the SQL Server purchased the module from the Sybase. So nowadays the SQL Server support the multiple transaction actually purchased from the Sybase, the transaction module. So Sybase is one of the best in terms of the academia or something, the algorithm, okay? So, which means the Sybase actually tried to their best to implement original idea of the database system. But Oracle, one of the terror, the DBMS. Why? Actually, their main module is the same as 30 years ago when they released the first commercial relational DBMS. It's still the same. That's the reason I'm still using the Oracle database. Even when I learned the Oracle first time, the version was 6 point something, and quickly moved to the 7. Right now, 12. But I can use the same command, the same interface. Then they add, whenever they there exists a new requirement or need from the customer, they add, so it's too big to manage. But still, first market share, because Oracle has a very, very nice online transaction management, which means at the same time, many transactions can access the same data, they can manage very well for such an online transaction. We will see. We will have a time discuss more about it. Database user is not very important, but as you know, we have the 17 different types. So this is the old job, database administrator, like the system administrator, Unix administrator, or network administrator. We need a database administrator. It's kind of a super user in operating system, or root user in the operating system. So sometimes it's called the DBA, okay? High payroll. Really? So you can get quickly the 150,000 yearly salary if you have the reasonable experience, at least 4 years. Problem? It's very hard to get the entry level of the database administrator. That's the problem. I was lucky because I was picked by my supervisor at the time. He needed the junior level, the database administrator. But it's even in United States, it's very hard to get the entry level, the database administrator. Instead, they usually assign one of the project members as the database administrator when they develop the system. Then, if the customer or company need, then pick up. And why don't you do the administrative job? Then, the time, the stack up the experience, then the move to another company as a senior level. So usually when you have the 7 years old experience on the database, it's called the senior level, you can get easily the high payroll. But somebody asked, why don't you move to? So definitely the salary, in terms of salary, the professor is less than the database administrator. I don't want to go back to industry again. So we will see later. Anyway, it depends on. So database designer, so focusing on the conceptual level design. So you don't need any specific the database skills sometimes. Instead, the domain expertise is more important. And the user, okay? Nowadays, it's more the detailed for the database user system analysis because of what? Importance of the data, especially big data. So big data is nothing but just the big data, but it means data analytics. So we try to get the valuable information from the data. So at the time it's called the system analysis or application programmer. That's easily you can imagine what are they doing. And the business analyst, it's a little bit different. System analyst focus on the analyze the system, the IT environment, IT equipment, like the network analysis or the system, performance of the system. But business analyst is who will be the target customer or where we are going to sell the new productions like that using the data. So if you are interested in such a business analysis or the data analytics, so you can take the big data system or the data mining course later after you complete this one. I already explained most of the thing, okay? From time to time, I'm going to show introduce the history of the database system, not this one. But, okay. But it is true, nowadays it has been, I think the database system started from the relational database. So relational database is with the Unix-based open system. It's 1980, middle of the 1980. Okay, which means it's 30 years, around 30 years. But the last 30 years, still the Oracle, for example, the relational database model is the top, the database model in the database system. It's very hard to move forward. Why? Because Oracle Informix is owned by the IBM DB2, Microsoft SQL Server, and even MySQL is owned by the nowadays Oracle. These are the major DBMS systems owned by the big company. They don't want to share their pie. They already got this amount of the pie. So even though the customer need, for example, new paradigm, new database model, they don't want to be risky, right? If they change their database model from the relational model to the object-oriented model, it will be the new error. So nobody knows who will be the first market share, second one. So they don't want to be risky. So they actually didn't put a lot of effort to move forward of the database model. But nowadays, because of the big data, it's getting changed, the NoSQL database. So do not ignore the NoSQL database. So probably next few decades, still relational database and the NoSQL database will move together. Okay? That's what I'm thinking. So DBMS is always the best solution? No, as we had discussed before, not always, especially when we have the small size of the data. You don't have to spend a lot of money for the license. Do you know how much expensive the Oracle license is? It's very expensive. Also, you need to pay every year 20 to 25% maintenance fee. Even though you don't get any the maintenance service, you need to pay. Sometimes it's very hard to, when you call to the customer service, they don't reply anything. It takes a year. That's true. But you need to pay 20 to 25% of the license fee. So if you pay the million for the license, every year you need to pay 200,000. Only for the maintenance fee. Otherwise, you cannot get any service, or you cannot upgrade. When you upgrade, you need to pay the upgrade fee and the labor fee, whatever. So it's very expensive. So small amount of data, you don't have to. Instead, you do better, memorize. Or sometimes Microsoft actually is better. Okay. And not always the relational database or DBMS is feasible for the data, depending on the data type. For example, I have a lot of image data. Even though they claim, the existing DBMS company, they said they can support the multimedia data, image and the video, or the document for to manage such a data. No, that doesn't work very well. 99% of the current customer use the relational RDBMS for alphanumeric data only. Okay, so how can we support such a multimedia data? File system is one of the way, and there are the NoSQL database that can support unstructured the database. Okay. Any question? Okay. Still introduction. I hope we finish the introduction part of the database, and also throughout the semester, from time to time, when we have a time, I'd like to introduce more interesting, like the history of the database and the market share of the DBMS in the industry. So there might be a time to introduce such a thing. And what is the limitation? What is the future of the DBMS and NoSQL database? Okay, in chapter 2. So we will talk about the basic concept of the data and database model and database application and database system. What is a model? You probably use a lot in computer science subject, modeling, right? And the software model. What is a model in computer science?
A
set of concepts.
Hmm?
A set of concepts.
Concept, set of concept. Yes, that's the textbook answer.
What we think we implemented. A blueprint. A blueprint.
Loop,
Blueprint.
blueprint. Blueprint, slightly different, I think. Okay. So, what is a model? Model means it's a kind of a template, idea, standard, right? As I mentioned the probably last class, the fashion model. We don't need the most beautiful woman or the most handsome guy, right? When you have a fashion show, you need a model who can show off mostly the clothes, right? At that time, we need the ideal body, right? What, 6 feet? But anyway, so we need the ideal body. Even some of the fashion designers, they don't want the beautiful face. Instead, not specific, but the ideal. So it's the same thing. When we are using the name of a model in the computer science, we need something template, we need something, the rules or concept that satisfy with the requirement. Okay? When you are designing network model, in network there might be something requirement. We need to send the data, and that data should be sent perfectly. So we are going to design the model. So eventually, so we can develop the protocol between the sender and the receiver, something like that. Yes,
Can the model be considered a data structure?
that's my answer. You already took my course.
Yes.
So eventually, so what he is saying then, what about the data structure? In computer science, how can we define such a model? So we have the requirement to keep the data, very large data, and efficiently, and to support the multi-view and the abstract level. Then we have the certain concept. Then how can we implement such a model? That is the data structure. Eventually, we will build a certain set of data structure. It's considered as the rule, set of rule or set of the concept. That is the model, especially data model in this class. So data model is a structure. Okay, and also this concept include several operations. One, using that model, are you going to just watch the database that you create? Eventually, you want to use that database model. Sometimes I use the example of the building house to explain about the developing the database. So using the blueprint, okay. So we try to build a house, something design, and so building a house is similar as a building, database. Then eventually you want to use that house, right? You don't want to just display your house. Same thing. So to do that, we need some operation. And that house is related, something condition or something requirement that can be implemented by the constraint. For example, one of the examples very tasty of such a constraint is, have you ever heard about the primary key?
Yeah.
What is a primary key?
It's a unique key.
It's a unique key, everybody knows. So unique key is one of the examples of the constraint in data model. Why? Because in our database, a very large database, we'd like to find the data very quickly, right? How can? If we have the unique data, okay, for the specific, the column or attribute of that data, that is considered as the key or primary key. So that's the example of the constraint. Okay. Sometimes it's called element, or the group of element is so element is the element. Then you can understand why the author of this textbook used the element to explain about the data. It's from what? Set theory. It's the same meaning. Element or record. You are familiar with a record or row. So if you think about the Microsoft Excel, row and column, it's the same meaning. Row or the record or line or data. It's an element in terms of set theory. Then our goal is to grouping. Group of data, group of element is called entity. Or sometimes a record or table. Or sometimes it's called set, not much set, relation. Relation is not here, relation. Relation is the different name of the set. That's our goal of the data model. In other words, if we can find such a set of entities, set of tables, such element, what also relationship, that's the data model. Okay? And operation means create the table or insert the data, delete the data, and do something operation to use the house that you build. Okay? You should know how to open the door and how to turn it on. Same thing, how to manipulate the data. That's the operation. There are different types of the model. Don't worry this one. And mostly conceptual level. I don't like such a category, classification of the data model. I like the only conceptual model and physical model. This implementation data model and self-describing data model is not general term. The Dr. Elmersly, author of this textbook, put this one and this one. But when we are saying the data model, it's two types of the data model. Conceptual level and physical level. Do you remember? Here. From information. Information is everywhere. It's not structured. It's not organized. It's not grouping. From information, we cannot keep all the information. That can be done the Google. Okay? It's not a database. It's a file system basically. So we are going to use the database system. To do that, we need to model, collect the related data based on our definition of the data and database. Collect. Then that's called the conceptual level. Or sometimes it's called the high level. It's called the semantic level. Why is it called the semantic level? Meaning is important. Character type, integer type, no, we don't care. Meaning, for example, in the university. So we have all the information about the university. So our goal is to build a university database. So conceptual data model means, so we try to find the meaning of such information. What's the important meaning in this student? So student, find the student. And also grade of the student. And instructor, TA, something like that. So try to find the meaning of the data that is called the conceptual level. Conceptual level, do you need any programming skill here? You don't need. But if you have, that's much better. So that is the reason I push a lot the student to be familiar with the domain, especially data domain, especially what? Finance. If we know the business flow and the money flow, that will be much, much helpful when you design the data and the database. Because you are expertise on computer science and programming. You know how it can be handled later, right? So do not set aside, do not focus on only the computer science skill. So .NET, how to create the very fancy, nice interface and how to build, okay? That's important in your class, but also open your mind to other data domain. So domain expertise is more important, especially in the big data era. Okay, the data will be money. Data will be money. So that's the conceptual design. Then the next step is anyway we try to build a database system using what? Software. So DBMS, Oracle Informatics DB2 is the example of the software. So we need to model. At that time, that's called the physical model, low-level model, or internal model. Why? It's a low level because we are getting close to the computer machine. Machine is usually low level, it's called. Instead, high level means the user friendly, like the high level language and low level language. High level language is the C or Java or the .NET, and low level language is a machine language, assembly language. So that's the reason it's called the low level internal. At the time, you should know how to create the table. Okay? And at the time, you should know what kind of data type you are going to use. For the name, variable character, what character. For the salary, the integer, or with the precision, the whatever. So you should know the computer science stuff and the physical data. So because of that, when you search a job, so sometimes the job description asks 3 years of the conceptual level design, or the high level, the data model, or the plus 4 years of the database model, or the physical data model experience. Okay? At that time, if you do not understand what's the difference, I don't think you can be successful when you search a job. In addition to this one, so in your project A, you are going to follow this step. First, decide the topic, then do the conceptual design, conceptual modeling, and physical database modeling. Then eventually you will implement the application program to access your database. That's it. That's what you are going to do throughout the semester in project A. Then next implementation level and the self-describing data model is, I don't think it's very important, so you can ignore that. So finally, output of such a database model, physical data model, is called the database schema. What is a schema? It's the answer here. Database schema is the description of your database. If you are building the house, what is the description of your house? It's a blueprint, outline. Okay, it describe your new house. Then using that description, you can create, right? So it's the same thing. Output of the database schema is a description of your database. Still not sure what is the schema. So let's see the example. This is a schema. Your goal is to find from the university database, if you can find the student. Student consists of a name, student number, class, and major. And also course consists of name, number, hours, and the department. That is your goal to find. So these are called as database schema. Especially we are using the diagram. Diagram is always much easier to understand, right? So this is called database schema diagram. So if we can find this one, then pretty much enough for your modeling. However, in this case, because you already know most about this university data, it's easy to understand. But what about the real database project? Without understanding the data and the business, it's very hard to the modeling, especially conceptual level modeling. Okay? So that is called the database schema. Okay? Database state means at certain time, for example, in this case, this is right now the status of our database, for example. Then it has a schema, right? Student has name, student number, class, and major, and so on. Also, in addition to the schema, we have real data instances. So schema plus data are called database state, current state of the database. So your goal of the project is to make the certain database state. Okay? So which means after design, you need to insert the data, sample data into your database also. Okay? So this is a database schema, and especially it's called the schema diagram. This is a database state. that we are going to build. Okay? So, there's one, I think that this one is the most important concept in today's class. So, three schema architecture. So far we have discussed a lot about the database, right? So, characteristic of the database, and it has a self-describing nature and support the multiple transaction, and there is a different view and so on. Then, how is there any standard to represent such a characteristic? ANSI standard. ANSI is the American standard, whatever. It's a standard. They define the three schema architecture that satisfy with the all previous the characteristic of the database. That consists of database model, include external view, conceptual view, and internal view. Three levels of the view, three schema. So what we are going to model in our modeling is conceptual level schema. It doesn't require any computer science skill. We don't know how it's going to be stored and how it's going to be created, just a conceptual schema. Okay, like the student. Student consists of a name, ID, and so on. But it can be viewed differently. Like the payroll officer view has only social security number and so on. And but by the department, each department can see the academic record of the same conceptual view. Then, who are going to design this conceptual schema? Designer, okay, or consultant, or the you. So we can design. Then, internal schema means how, for example, student is stored. For example, we are going to use the file system on the C drive data, and this is the table space 1.dbf file. In the table space 1 dbf file, it will be stored the first block to the 100 block, something like that. Okay, and the name is 100 byte, and ID is a 9 number, and so on. Very detailed low-level data structure. This is called internal schema. When you create the table, like the student, do you need to know internal schema? In file system, you should know. But database, you don't have to. Who is in charge of that part? Who is responsible for that?
Database management system.
Database management system, DBMS, will take care of everything. That is the benefit of using this one. So, ANSI standards propose such a three schema architecture to support various characteristics or advantage of using the database that we discussed. To support them, we propose these three schema architecture. So current DBMS system, especially relational database management system, support this one. Especially external view will be implemented later. This view. We are going to create the view. We will see later. Okay? So this is the three schema architecture. Because of that three schema architecture, we can get the whole benefit of using database. Okay? Okay, so I don't think so we can finish or end of the chapter 2, but pretty much before we start the data model. So from the next week, I already explained all the roadmap of the semester. So we are going to start from what? Conceptual model, data model. Then move to the physical model or low-level model. And using the database, we will create the table. Eventually, we should be able to access such a data from application. Okay, before we start the data, the conceptual model, I will finish the chapter 2. Any question? Don't forget to inform the project topic to the GA. And also, we have the GA who can help throughout the semester. Anas?
Yeah, hello everybody. My name is Anas. I will be your GA for this semester. There is another GA, his name is Namzi, so also we will try to help you as much as we can throughout the semester.
The Anas and Namzi are the, believe me, it's a really top 2 student in my previous class, and also he is a PhD student, so he can help a lot. So this semester you are lucky. We have a very small size, reasonable size the class, and also we have the 2 very nice, wonderful GAs. So please try to do your best to get the help from him. Sometimes latest technology, he is better than me. So I'm old-fashioned. So thanks so much, and have a great weekend. We will see on. Is there any homework before I finalize? I don't think it's the first week, but why don't you make the group by 2, right? Project 8, then inform to the GA. Hopefully, I think that throughout the semester, because we have the small size, so we can have the from time to time check up of your project, like the presentation or something, the discussion time. Okay? But undergraduate student, you guys already form a team and writing for me. Okay, thanks so much, and see you next week.